Okay, for part C, we're asked to find the median of x. Now, the median of a probability distribution function is the value from uh, the beginning of our sort of limits of integration. So in this case, it was 0.5 up to some number. I'll call it m of our function, and that has to equal 0.5. Okay, so it's when we integrate and we get the area under the curve would be 0.5. Now, there's a couple of ways you can solve this on the calculator. You can use the numerical solver, or we can just graph it. And I personally prefer graphing them because sometimes with if we're using the numerical solver, we have to know sort of the bounds and things like that. And it may take us a couple of goes to get it. But this one's not too bad because we know the function here, m, well, it's going to have to be bigger than 0.5, and it's going to have to be less than 3. So you can limit the bounds quite easily for one like this. But we'll go ahead and graph it. Okay, so we'll put in our first function. So it's going to be, I'll put the 6 over 85 first, actually. So it's going to be 6 over 85 times the integral. And we're going to go from 0.5, I'll just call it x, because that's what we're graphing in terms of x. And then we've got our function in here. So it's going to be 4, and then plus 3. I'm going to use a dummy variable, say r, because we don't want the calculator to get confused with the x, because we're already using x here. That's the thing we're trying to solve. And this is a definite integral, so it doesn't actually matter which letter we put here, because we're going to be substituting in those limits of integration anyway, and we're going to end up with a function in terms of x. Okay, so it's going to be plus 3r and then minus r squared, and integrate that with respect to r. So this is just going to turn out to be a function in x if we decided to, say, integrate it by hand and then do it that way. So we've got the calculator here, so we'll let the calculator do the work for us. Okay, so there's the function 1. And we know we're going to be between 0.5 and 3. So I might just change the window a bit here. So if we go window, so I'll make x say 0.4, just give us a bit of space on either side, and about 3.1. And I'll change the y to say -1, and say about 5. Okay, so there it is there. Now we just graph half. So a function, so that is equal to 0.5. And we can see the intersection there. So then we just analyze the graph, find the intersection, and there it is there. Okay, so 1.687 to 4 significant figures, so that'll be enough. So therefore we can say m is going to be equal to 1.687, and to 3 significant figures in, it is going to be 1.69 to 3 significant figures.